So you have this unit circle, and here the S is positive. So this S is the inverse sine of A. And then at the same time, you can find another special solution by using the pi minus S. Pi minus S is just this angle. So this guy here is the pi minus S. And then use these two special angles and add the multiple of 2 pi to them, you can form the general solution. So this case, when this S is positive. Now let's look at the case when the S is negative. So now, if the S is negative, first we may find the corresponding smallest positive angle which is coterminal with this S. So we just add the 2 pi to this S, then we get one special solution which is between the 0 and 2 pi. And then to find another solution, you use the pi minus S. So this is another special solution between the 0 and 2 pi. And after you find these two special solutions, you add the multiple of 2 pi to them to form the general solution. Now let's show this in the figure. So let me draw another unit circle. So this time our S is negative, like this. So this is S. And then we can use the plus, okay, we can use the 2 pi plus S to get one angle which is between the 0 and 2 pi at the same time coterminal with this S. So that is the 2 pi plus S. So this guy here, this is the 2 pi plus S. Okay, so here this S is negative. So S is less than 0. And then we can also find another special solution between the 0 and 2 pi. So actually is this angle. And for these two terminal sides, their terminal point has the given A as the y coordinate. So this angle, this guy, can be obtained by pi minus this S. Okay, so actually you see this S is negative, right? So you can find the corresponding angle here. This is positive S. Okay, the opposite of S. Then that is a negative S. Negative S is positive, and then plus pi, then you get this angle. So this is pi minus S, the second special solution. So now, by now we have finished the case when the A is between the -1 and 1. And for the other special solution, say when A is equal to 1, 0, -1, okay, you can find the corresponding solution set like this. And when the absolute value of A is greater than 1, then this equation has no solution. So much about the trigonometric function involving the sine function. Now, let's continue to solve one more trigonometric function involving the tangent. Okay, and let's go to the page 567. We'll try to solve the problem 18. So page 567, problem 18, and we have the tangent x equal to negative root of 3. We can always use the inverse function to find one special solution. Okay, so let's first get the first special solution, small s, which is equal to inverse tangent of the negative root of 3. Tell me what is the inverse tangent of the negative root of 3? What is that angle? What is the inverse tangent of root of 3? Pi over what? Pi over 3, right? Then what is the inverse tangent of the negative root of 3? Negative pi over 3, right? Because the range for the inverse tangent function is between the negative half pi and half pi. So after we find this special solution, then we can find the smallest positive angle, for which the tangent is equal to negative root of 3. Because the period of the tangent function is equal to pi, right? So we know the period of tangent is equal to pi. So we will just add pi to this angle, this negative angle, to get the smallest positive solution to this equation. So you add the pi to this negative pi over 3, then you have the 2 pi over 3. Then after you find this angle, you can add the multiple of the period of the tangent function, so that is a multiple of pi, to this special solution to find the general solution, for this equation. So now the solution set S is equal to the set of x, such that x is equal to 2 pi over 3 plus k pi. So in this way, we find the solution set. Now let's look at the page 560. Here is the summary for solving the tangent x equal to a. So first, you use the inverse tangent function to find the one special solution. That is the inverse tangent of a. And since the tangent, for the tangent, the range is the set of all real numbers. So in this case, for any real number a, this function, this equation always has a solution. So we don't care about the value of a. So any real number a, this equation has a solution. And now, if this S, this special solution, is non-negative, then you may directly add the multiple of pi to this special solution to form the general solution. And if the S is negative, as in our example, you can add the period of the tangent function to this S to get the smallest positive solution, and then add the multiple of pi to this special solution to form the general solution. So for the case of the tangent x equal to a, the solution set is comparatively simple compared to the case of the sine x equal to a and cosine x equal to a. Now, let's look at the equations involving the multiple of angles. So we'll deal with some equations which involves the multiple of angles.